Hello guys, I'm your teacher Olimboka Sajiga Masame. Let us have a look on a question below concerning relativity between a plane A and plane B. The plane A traveling at a speed of 60 meters per second due north, and the plane B traveling at 80 meters per second due east. If asked to find the relative velocity of plane A with respect to plane B as observed by an observer A in plane B and B on the ground. Let us begin with observer on the ground. First method we use here is graphical method, and we choose a scale that 1 centimeter on the graph represents 20 meters per second. Okay, for velocity VA will be equal to 3 centimeter and velocity VB equal to 4 centimeter. Then this is the point where our observer placed his frame of reference from the ground, and this is direction for vector OA represent for plane A and vector AB represent for plane B. Then the resultant is from O to B. This is velocity of A with respect to B as observed by stationary observer from the ground, that will be represented by letter E as observer from the S or ground. And the angle in which this resultant headings is as a letter beta from due east, or letter theta as east of north. Okay, let us resultant, after measuring the resultant, we get this length equal to 5 centimeter. Then from our scale, our 5 centimeter is equal to 100 meters per second, and our angle from there is 37 from due east. And for a case B, for case A as observed by observer B, is when now our observer B, we extend the magnitude of this vector B from the initial one as an observer as our origin source now, where the observations will take place to this point B dash, and then the resultant of velocity of A relative to B with respect to observer B will be equal to a line drawn from O to B dash, and this is velocity, and the resultant is equal to 80.5 centimeter. Now when we take this into the scale here, we get 170 meters per second as 21 degrees from due east. Okay, let us consider the mathematical method below. As we're using the vector addition rule, we're adding the vectors, and the magnitude is 100 meters per second as usual. As you can see from the diagrams here, that is adjacent now is 80 meters per second, and the opposite is 60 meters per second, and our direction is 36.9 from due east, 36.9 from due east here, just a beta, which is 36.9 from due east, or 53.1 degrees east of north, 51, that is angle theta. Now for a party A, velocity of plane A relative to B as observed by observer B in a moving plane is equal to, from vector addition rule, is equal to, we add this vector AB plus vector B. Now then we apply the magnitudes of the vector AB, then the unit vector will be equal to 1, and our result is 170.88 meters per second, and the direction is from 20.6 degrees from due east, or 69.4 degrees east of nose. As you can see here, these are directions of our resultant of when the observer B observing the motions of resultant VAB with respect to the plane where the observer B is inside. Now our representations where we can find the angle, as you can see here, our vectors, and from cosine rules you can see how we can solve these questions by applying cosine rule. Then as you can see, our angle for resultant VAB as observed by B is equal to 143.1 degrees, and our result is very close to the one with the other methods. Now you may like and share, comment, don't forget to subscribe for more video like this ones. And as you can see here, the observer B will see the plane A is far behind the plane B. This is always the same for the both cases. Thank you for watching, and see you next time.